Hello and welcome to this installation of our plant engineering video conversation. I'm your host, Amara Rozgis. I'm the editor-in-chief of Plant Engineering, and I've connected with Julian Real and Neal Mukherjee. We're going to talk about controlling air compressors and the many topics surrounding it. Thanks for joining me today, Neal and Julian.
Thank you.
Awesome. Well, here is some background about my guests. Julian Real is with Atlas Copco Compressors, where he has developed deep worldwide expertise across both technical and commercial functions and is currently the Central Controller's Product Marketing Manager. Neal Mukherjee is the VP Business Line Manager for Atlas Copco Compressors, stationary electric large air compressors in the USA. He's been with Atlas Copco in the compressed air business since 2006. All right, let's kick this off right at the top. We know and we've heard in the past that some plants must sacrifice simplicity and accessibility to the data of their compressors in favor of energy efficiency. Or on the other end, people need to sacrifice efficiency to opt into automation. What's your take on this, Julian and Neal?
Yeah, thank you so much, Amara. And first of all, our take is that we don't think that the customer needs to choose one over the other. But first, I would like to talk about how our air compressors are actually or traditionally controlled on their own, which depends mostly on how old the compressor is, the type of technology, the size in horsepower or flow, and some other factors. But on the most basic level, they all have on or off buttons and a pressure switch to regulate on. So based on the pressure of that switch, when the pressure drops below the set point predefined on that switch, the compressor starts and makes air. And as the pressure increases and we reach the set point defined by that switch, then the compressor stops. And that's on the most basic level. But bigger, more industrial ones, they have dedicated PLCs, computers that are pulling the information from all the sensors like pressure, temp that are installed on that compressor. They gather all that data and they have smart logic that allows them not only to control, but also to protect that machine.
Yeah, and some others like our Electronicon microprocessor controller can even upload information to the cloud so that customers can monitor everything that happens in the compressor room or even access equipment documentation directly from their smartphone. This is one-way communication. We wouldn't want to have a risk of possibility of sending data to the cloud or anything that could have any cybersecurity implications or risks. Uploading the data to a smart, secure, and robust platforms allows customers to manage their assets and also monitor and plan preventative maintenance to increase reliability. You could say that this is a smart link between the compressors and the customer.
Okay, so you just
that's
mentioned,
correct.
sorry, Julian, you did just mention this, and tell me, what's a central controller or master panel, as some people call it?
Yeah, so as I was talking also earlier, so compressors, they have their own standalone controller. But when the customer has multiple compressors, they need a way to start and stop them in harmony. And usually what they do is they stagger them or they cascade them, and they need to define a sort of lead lag sequences. But a master panel or a central controller, it's a device that gathers all the data from all the units in the room, all the machines that are part of the process, and it acts as a central point and a hub, not only to control them, but also to monitor them and provide our customers with insight on what's happening, not only on those compressors themselves, but any components that surround them and that are directly or indirectly part of the process in any way. So anything that's related to the compressed air system, there's usually value on gathering data, information on it for future trends and to provide our customers with insight on what's happening on their installation. So I would say that in a nutshell, a central controller is a smart device that makes a plant more efficient. It streamlines it, it harmonizes the operation of the entire system with automation, reliability, and also peace of mind to our customers so they can focus on growing their production, knowing that the compressed air installation is well taken care of.
Okay, Neal, from your vantage point, what does it do and why would you consider it important to have one?
That's a great question, Amara. A central controller is a core component of any installation with multiple air compressors. Can monitor plant pressure and compressed air consumption, can have a smart algorithm that determines the most energy efficient combination of compressors while also maintaining the pressure that the plant needs, maximizing energy savings and reducing CO2 emissions. It also balances the running hours of all the equipment and makes sure that every machine sees some runtime and also protects the installation. Another thing to point out is that by some estimates, 20 to 40% of the total cost of the electricity of the plant is used by the compressed air systems alone. What this means is that a true central controller should have the capabilities of controlling and monitoring not only compressors, but also other equipment related to the compressed air system, such as compressed air dryers, nitrogen or oxygen generators, particle filters, oil filters, flow, dew point, everything that can be monitored through a central controller.
Okay, so you mentioned this at the beginning. How would that be different from just staggering compressors on their own? You talked about a lead lag fashion. Julian, let's start with you.
Yeah, thanks, Amara. So first of all, when you only have one or two compressors, it's very simple to stagger them or cascade them. But every time when you do this, when you stagger those compressors, you need to have a difference between them on the set point of the pressure that they're going to run at of several psi between one machine to the next one to prevent them from fighting with each other. And that only if you want to maintain the pressure on that threshold. So the more machines that you have, the more compressors that you add and that you cascade, the wider that pressure band is going to be. The more compressors that you have and the wider that pressure band is, then that's also going to increase the total energy consumption of the installation. So what the central controller does is that it's going to run the system based on one single pressure set point. We take one measurement on the point of use or the point where the customer uses that air, the point that actually matters to them, and we run the required compressors to maintain the pressure on that point. That way, there is no need to mess with different settings throughout the system on every single one of the machines. It's also important to know that there are several types of central controllers. There's not just one flavor. The most basic ones, they're actually not controllers or optimizers. They're basically sequencers. So all that they do is start and stop compressors in a predefined order based on size of the compressors or how the customer prefers to stagger them or cascade them. But then on the other hand, we also have more advanced controllers that make real-time computations, and those are the ones that actually optimize the entire system. These are the ones that will benefit the customer the most. They can not only monitor but control not only the compressors themselves, but they extend this functionality to other pieces of equipment that they have in the compressed air room.
Yeah, Julian, as you know, we just finished a project last month where a customer needed a fully automated system where reliability was a key factor. For that customer, as you know, the central controller guaranteed that the compressors were running at their most efficient point, controlling how many dryers are operational based on the actual compressed air demand, having fully automated valves. And the site is really running fully automated without a single person actually there on site to manage it. In this case, the central controller is not only providing energy savings, but reducing maintenance expectations on compressors and dryers, protecting the dryers from under or overloading, and also has an automatic backup functionality so that if compressor or dryers become unavailable, or if the dew point decays, for example, it's going to be automatically replaced with another machine in the system.
It sounds to me like a lot of data is created. So, what about customers who want to access their data from the compressor? Julian, I'll start with you there.
Thanks. One of the things that we believe the most in is that the customer should be able to access and know everything that's happening. Just because there is a central controller in the room, it doesn't mean that the customer will be locked out of that data. It's their compressor, it's their installation, so they should be able to tap into all the information that's going on through it and act and use it for anything else that they want to create reports or use it to control different systems throughout their plant as well. So with systems that we designed, we make sure that it's important that the central controller takes this information information and sends it over to them. It's critical to provide industrial communications as part of central control solutions so they can access all this data. We know as leaders in our industry that around 75% of industrial communications are nowadays based on Ethernet protocols. That's why we also invest a lot and heavily in providing these communication protocols to our customers. They should be able to use Profinet, Ethernet IP, Modbus TCP IP, BACnet IP. These are just some of the few communication protocols that are mostly and widely used in the industry, and they should be available on every type of central controller so the customer can access the information on their machines.
Yeah, of course, that's on the local level, but there's also the smart link to the cloud we mentioned earlier, where customers can access this data, even advanced insights and notifications, potentially generated by AI even.
Yeah, and it's interesting that you mentioned artificial intelligence. How do you think AI can impact the way central controllers work? Obviously, that it goes to the customer then. And how can this help solve those pain points of centralizing the controls?
Well, I think AI is a very powerful tool, and there is a lot of potential, especially when we have central controllers. And companies can leverage it in so many ways. Installations, for example, plans and their demand, they're not fixed, they're not stable, they are evolving, they change over time. Customers add new machines to their production lines. Maybe some equipment is no longer available because it's being serviced or it's out of operation. Even leaks in their air pipings increase over time. And this affects the reaction time of the system. A real smart central controller, it needs to be able to dynamically adapt to all these changes on its own. Now, imagine that you can take the combined power of the best service technicians in the world, the best engineering minds, put it on a box and make it available on site for the customer. They will be detecting all these changes in real time and not only react, but adapt and proactively tune and adjust the system so the installation is always running top notch and it's always saving energy and automating itself, guaranteeing reliability as well. That's one of the many ways in which our companies uses AI to benefit our customers. We can increase the stability of the pressure even on dynamic conditions. They reduce maintenance, energy consumption, and minimize even more the risk of any unplanned downtime. And of course, cybersecurity should always be a top priority. So we feel that whenever AI is involved, it should be done in a local level. It shouldn't be cloud-based. It shouldn't be able to be accessed remotely. There should be a way to lock it down if the customer wants to just keep it inside that box and make sure that there's no cybersecurity risk to them or their process.
Okay, so then, Neal, let me ask you first. Could AI be used to anticipate failures or inefficiencies even in compressed air systems?
Yes, absolutely. One of the advantages of having a central control system is being able to control the entire utilities room and also monitor it. Since everything is already connected to the controller, they can analyze the data, including the health of every machine based on the sensors, and proactively generate warnings and even potentially tune the system to prevent further degradation. Julian, I think you also have
Yeah.
some thoughts on that.
Yeah, indeed. And what you mentioned, I think it's very important because the more data that it's measured in a plant, the more data the customer gets, the more it can be analyzed and integrated into other systems. And it can better be used to predict and generate smart insight. It can optimize the compressor room, increase uptime, efficiency, and sustainability for every customer. We know that for some companies, AI is the future, but it should be something that it's right here, right now. The future is already here, and we all need to find the best way to implement it and use it for our and our customers' advantage, especially when we're talking about centralized control systems.
Well, that's a lot to think about. Thank you so much, Julian. Thank you, Neal, for joining me today. It was great to chat with both of you.
Thank you for having us.
Thank you so much, Amara.
Yes. And that was Julian Riel and Neal Mukherjee talking about several aspects of correctly controlling compressors in simple but efficient ways. For more information on air compressors, visit Plant Engineering, plantengineering.com. Thank you so much for joining us, and we will see you next time. Bye-bye.